So another opportunity for us to investigate these vector fields at specific points looks at the idea of a divergence. Now, divergence is basically how quickly that a mass, fluid, or gas, or even a wind or magnet or something like that flows either to or from a point per volume of unit. All right. So think of, like, for example, in the desert, if you have a sinkhole, all right, then essentially if you have like the quicksand and everything's going into that quicksand, that would be the idea of divergence at a specific point. All right, that's a pretty good one. Or even going down the drain, if you have a vortex and you have water that's going down a drain, we're talking about how quickly the water is going down the drain or how quickly the sand is going into the hole. Or if you have a magnet that's repelling some sort of radioactive waves or something like that, that would be a positive divergence because it's going away from a specific point. So it doesn't necessarily have to be a sinkhole, if anything like that. It could be the other idea in which things are flowing out of that. Right? So it's really easy to be able to compute the divergence. Divergence is going to be a constant because it's a rate. All right. In fact, so it's just basically going to say how quickly it's moving. So unlike our curl, which is going to be a vector, divergence is going to be a constant. And assuming that all the partials exist, then the divergence of F is very easy to compute. Div of F is going to be partial of each of the components of the vector, P, Q, and R, with respect to X, Y, and Z. It's actually fairly easy to compute. If the divergence for some reason equals 0, then the vector field F is said to be incompressible. All right? And then finally, the divergence of the curl. So if you find the curl and then find the divergence of that curl, that's always going to be 0. All right? So in other words, the rate of change of the curl is going to be 0 for each of the vectors that we find. All right, so let's just really quickly find a couple examples of being able to find the divergence, and it's not too difficult. So we're going to define xy as p, we're going to define yz as q, and we're going to define zx as r. And all we're going to do is find each of the partials. So we're going to say partial of p with respect to x is y. The partial of q with respect to y is going to be equal to z. And then finally, the partial of r with respect to z is going to be x. Right? So if I wanted to find the divergence of F, right, well, that's going to be equal to y plus z plus x. So all we're doing is just taking each of the partials, and that tells us what the rate of change is at a specific point. All right, so in other words, how quickly are things flowing either to or from that point. Right. A second example. So this time we have x e to the yi plus y e to the zk, and we're asked to find the divergence. Again, let's define p to be x e to the y. We're going to define q at this point to be 0 because there is no q. Right? And then finally r is going to be this y e to the z. Okay, so r, not the vector part of it, or not the k, all right? And p is going to be this x e to the y, and then q is equal to 0. Right? So the partial of p with respect to x is going to be e to the y. The partial of q with respect to y or any variable is going to be 0. And then finally the partial of r with respect to z is going to be y e to the z. And so the divergence of our vector field F is going to be equal to e to the y plus y e to the z. All right. One thing that we noted above was that the divergence of the curl of any vector field is 0. So let's verify that for some specific vector field. Now we're not saying for every vector field, but we're just saying for one, just to show if it's true. And we're going to go ahead and we're going to just say that our vector field's an easy one, x, y, y, z, y, z. And we're just going to go through and try to figure out what the curl is first and then find the divergence of that. Okay, so to find the curl, first of all, we just set up our matrix. This one's actually going to be pretty easy because we don't have anything too long. Remember, you put the partials, so partial of x, partial of y, partial of z. So partial with respect to y, and then partial with respect to z. And then we just take each of the components of f, xy, yz, and then yz again, and we just throw it in there. Now let's just compute this really quickly so that way we can, we know how to compute our curl because we've already seen 3 other examples of it. So we cover up our I, we take the partial with respect to y of yz, which is z. The partial with respect to z of yz is going to be y. So that's y minus z I. Minus, we cover up the j column. Partial with respect to x of yz is 0. Partial with respect to z of xy is 0. And then finally, for k, we cover up the k column. Partial with respect to x of yz is 0. Partial with respect to y of xy is going to be x. Right? So we end up with a really nice and easy curl. So our curl is going to be z minus y I. There's nothing for j, and then minus xk. Now that's our curl. Now we're also asked to be able to find the divergence of this. All right, and divergence, we're just going to take all of the partials and be able to find those. All right, so let me see if I can. I'd like to be able to do it below, but it's not functioning for me. So let's just go ahead and I'll just hit enter. And we know that to be able to find the divergence of the curl of f, we're going to have to find the partial with respect to x of, let's go back, I forgot what the solution was. So the partial with respect to x of our z minus y plus the partial with respect to y of 0 plus the partial with respect to z of negative x. So this is the partial with respect to z of negative x. All right. And we can clearly see that this is going to work out really nicely to be 0, because if we take our partial with respect to x of z minus x, that's 0. Partial of any 0 is 0. Partial of z with respect to x, negative x is 0. So indeed, that does equal 0. All right, and that's what we wanted to see. All right, I think there's a problem like that on one of your quizzes or assignments, so that can help you to be able to see the process of that. Okay, so again, I did post some videos about the idea of what the divergence was. I think there's 5 of them. Some of them talk about the idea of a sink. Some of them talk about the idea, or one of them talks about a sink. One of them talks about a source. One of them talks about, or at least demonstrates, what a positive divergence is, and one which is a negative divergence. So take a look at those videos really quickly. They're pretty good, and they're pretty short videos just to give you a visual conception as to what divergence is, and then similarly with curl.